Right, yeah, thank you. So my name is Bart. I've been working at KU Leuven University across the street here, so at the Department of Mechanical Engineering, working on drones there. But recently I joined Flanders Make, and coincidence, I'm also working on drones there because they have lots of drone projects, and that's what I'm trying to present here today, shortly an overview of what we're doing there with drones. And after that, if there is a little bit of more time, I can show you a small overview of trends of this year to conclude the presentation today. So for those of you who don't know Flanders Make is an organization that tries to bring research that we have in our universities, tries to bridge the gap between universities and our industry in order to help our industry to stay competitive, have the latest new technology, and even have some innovative new solutions that we have here from our research institutions and implement it in their products or their processes. So where do drones situate at Flanders Make? So in Flanders Make there are lots of topics in which we are working on. One topic is autonomous moving and working. So we look at not only autonomous movements, typically you have passenger cars and public road transportation. That's not really our focus. We focus more on the other side, so really working functions. Working functions can be logistics, manufacturing, also agriculture, so fruit picking, harvesting. And then we also have, and that's where the drones are located, the air and water applications. So at the moment we don't have a lot of water applications, but we do have a lot of drone applications. What's a bit the focus, or where did we start with respect to drones? So we have a big background, or one focus area has always been sensor fusion with our software toolbox that we have, the OASE toolbox. It's online asynchronous state estimation. It means, so it's a big Kalman filter actually. We use different low-cost sensors often, and then we fuse them in order to have information from all the sensors in order to estimate the state of the vehicle, or in easy words, just to know where we are. So it's really close to what we've seen here today. So you can use cameras for SLAM, you can use LiDAR, you can use depth images, you can use IMUs. We also use other localization systems for indoor, outdoor, to all fuse that data in order to have our state estimation. Now, one demonstration we had to demonstrate this localization was flying a drone indoors between a warehouse. This is a DJI Matrice 100 drone. People will recognize this old platform already. What do we have there? Well, we have the ultrasound, one-dimensional distance sensors, which can be used for obstacle avoidance, but can also be used to make build a map where the obstacles are. Then we have visual SLAM. We have some cameras on top. It's not 360 degrees, but it's wide view. And then we also have at the top, the antenna is not completely visible there, but we also have an ultra-wide band system. I never used it since 1 or 2 months ago, and I must say I'm quite impressed with the system and how easy it's to set up and everything. So this is a small video that explains the project. It saves me the effort of explaining it myself. Yeah, so we have subtitles, but the sound will also come through, I hope. So it's a big
manueel proces brengt heel veel kosten met zich mee, zowel in termen van arbeidskracht als werkuur. Maar biedt ook risico's voor veiligheid en je persoon op hoogte moeten werken om de bovenste paletten in een recht te scannen. Daarnaast maken mensen ook gemakkelijk fouten, waardoor de nauwkeurigheid van de manuele inventarisatie vaak onder de 95% ligt. Het Inward Drones en Smart Connectivity project bij Flanders Make hebben gewerkt aan een geautomatiseerde oplossing hiervoor. waarbij een drone autonoom tussen de rekken vliegt en de paletten scant en lokaliseert in het magazijn. Voor het autonoom vliegen van de drone is de grootste uitdaging om ervoor te zorgen dat de drone zichzelf kan lokaliseren in het magazijn, omdat het GPS-signaal niet goed werkt in een gesloten gebouw. In plaats van op één dure technologie te vertrouwen, gebruiken we hier meerdere relatief goedkopere sensoren, zoals ultrawideband camera's en accelerometers. En door die verschillende sensorsignalen op een slimme manier te fuseren, zorgen we ervoor dat de zwaktes van de ene sensor worden opgevangen door de sterktes van de andere sensoren. Deze sensorfusieaanpak zorgt er ook voor dat de kostprijs van het totaalplaatje een groot ouder lager ligt dan de oplossing met slechts één sensor die dezelfde resultaten behaalt. Voor het scannen van de paletten hebben we een camerasysteem ontwikkeld dat licht is in gewicht en dat scherpe foto's kan maken van de rekken terwijl de drone in een snelle vlucht is. Op die foto's laten we dan een algoritme los dat de QR-codes scant die op de paletten bevestigd zijn. Traditionele algoritmes bleken helaas niet goed of snel genoeg te werken, waardoor we zelf een eigen algoritme ontwikkeld hebben dat betere resultaten haalt, omdat het enkele applicatiespecifieke parameters kan gebruiken, zoals de grootte van de QR-code die op voorhand gekend is. Met dit algoritme halen we een nauwkeurigheid van 99%, wat een stuk hoger ligt dan de 80% nauwkeurigheid voor traditionele algoritmes en ook hoger dan de 95% nauwkeurigheid van de manuele inventarisatie die ook veel langer duurt. En we halen die 99% nauwkeurigheid zelfs met drone-snelheden tot 3 meter per seconde, waardoor een drone slechts 3 minuten nodig heeft om een hele gang van 100 meter lang met 2 rekken van 4 niveaus te kunnen scannen.
Currently, this demonstration is running at Lockville, which is a big demonstrator for logistics applications, which also showed that the system is a bit robust because it's operated by just someone there who gives demonstrations, so a non-technical person. So it was quite a challenge to have the demo running there just with the push of a button. Then another use case, how to cope with the deteriorated GPS signal, which we have when you have typical applications. Also mentioned already today, it's not hard to fly outdoors when you have a large space and perfect GPS reception. It's not hard to follow the waypoints. But these missions are also used, for example, to make inspections of bridges. And then if you want to inspect the bridge from below, you have to fly below the bridge. And the drones that are on the market today, if they lose their GPS signal, one problem is that they might crash. They go to a manual mode and they might crash into the bridge. And another problem is, you're trying to detect some cracks or trying to build a 3D map of the structure, and if you don't know where the picture has been taken, it's hard to reconstruct it. So what are we going to do in this environment where GPS sometimes is good, sometimes is bad? That's the question that we get. We don't have directly an answer, but what we did last week was testing all the sensors that we had in-house. So we have some stereo cameras, we had a depth camera, we had the ultra wideband. We also have the GPS from the drone mounted on one platform manually, because we're not allowed to fly there with the big legally. So we missed the presentation, the legal presentation, but it's an issue. It's a big issue for drone development, the legal side. And now what you can also see is a very expensive camera system. So those are the sensors that were on board, and then we also have the Qualys sensor system, so it's with reflective markers, so it's a motion capture system that we recently invested in, and that gives us a ground truth to benchmark all kinds of localization techniques. So that's maybe also interesting for some future collaboration. If you have a good camera for localization, you want to benchmark it, maybe we can help with this system. We also test everything on our home-built, own-developed drones. This is because hardware in the drone world evolves so fast that if you buy a platform today, next year it's already discontinued. You don't find any replacement parts for it. So we try to just build everything in-house, so that if we have something broken, we can just print it again or cut it again, just from some basic materials and a limited number of suppliers. So then this is the real drone. You can also see that here the markers are mounted. It's not in this picture, but also here we have a stereo camera that we also use then for visual SLAM, combined with other sensors, so that you first fly around in an area to build a map, and then afterwards you use this map to localize where you are. And we do this not only with the visual system, but then also with the ultra-wideband system, and with depth camera, to augment all the images and to improve this. And then this indoor and outdoor. And some smaller side projects, more a bit of explorative. One project that personally I'm working on is the combination of a drone with a tractor, and then we have a tether between them. So it's a tether system like the one from Drone Matrix. And we use this, well, it's a demonstrator, but one application could be, so for the agricultural sector, that you have this drone, and then you can have different points of view outside of the cabin of the tractor, so that you can sense what is in front of the tractor, which could be used for crop monitoring, or that you have an image what you're going to harvest, but also to detect persons for safety, or some nice application to detect deer calves, so that you don't harvest the small cute animals, because it's not nice for the animal, but it's also not nice for the machine and the person who has to clean it up. This is our first prototype of demonstrator. Because we are not legally allowed to fly here around Leuven because of the Zaventem zone. We have to go somewhere a bit further away in the fields, and in order to make it practically to develop this application, we also have a small driving. So we packed everything in a small compact solution, so that we can just take it in a van and go somewhere in the field to test it, in order to have fast developments. And it could also be already some inspiration for some applications where I think, okay, we can also put it on a small automated ground vehicle, for example. Then another thing we are looking into is using a drone to scare away birds from orchards. The problem there is not on the drone side, well, maybe legally, but the problem there is to detect where the birds are, because the birds can be really small if you have one camera, maybe a 360-degree camera. To detect the birds 100 meters away, it's sometimes only a few pixels, and that's really hard to detect it. So we also look at different sensors, so a LiDAR sensor that could be used maybe to detect a bird, and then having a perimeter around the field, and if birds enter, the drone goes there to scare them away, so that they don't pick all the fruits. Another project is mapping mapping defects in 3D structures. So we have here a setup. It's at one of the big hangars in Droomport, and there we have some artificial cracks in the structure. And here the drone, it's not really a drone development. It's this flying camera, like many of the drone projects are flying camera projects. But here the drone is carrying a high resolution camera and takes a lot of pictures of the structure. And then two things are done. So if you have the pictures, we make a 3D model of the structure. And on the other hand, we detect cracks where they are. And we also see, we label the cracks. How big are they? How severe are they? How long, how wide are they? And then we combine it into one 3D model with then all the points of interest and a report of which crack is where and how severe it is. Then the team that works on vision, they have been working also, so you might recognize this from the first presentation today. It's the base station in Spain, I think, from Drone Matrix, to have the drone tracking the person. But on the other hand, we also have a question where the drone has to be tracked in the image for anti-drone measures, that we can track where the drone is and give an image of the drone or which drone it is, and keep it always in the image. So that's a brief overview of the drone projects. On the other hand, that's the research part, but we also do validating and testing. It's mainly in our premises in Lommel. In Lommel, so that's test facilities historically grown for the car industry, but it's also interesting. So we have a lot of battery test setups, drivetrain test setups, and it can be also used for drones. Well, maybe not necessary for the small drones, but if you look at the bigger professional drones or even drones for transport of people and bigger logistics, there it becomes necessary to test everything decently and accurately. And also some climate chambers, so small climate chambers for components of drones, or even a big climate chamber in which you can change temperature, humidity, the sun radiation, everything very fast to have a very fast life cycle test of products, and which can be also for whole drones. And if we have a bit more time, then I can quickly go through some highlights of this year that I collected, like from my daily news feed I get from social media and everything. Like, what are the trends that we have seen today? Well, this year, what I see is that industry is moving, like the typical drone camera industry for small cameras is moving, or what are there the innovations is that they're moving to very dynamic shots. So new products, they are designed to have very dynamic shots, go through small openings and have really dynamic shots, of course. So really action camera shots. We also see that there's a trend towards better connectivity. Also not a big surprise. So new drones on the market can have 4G connectivity so that you can fly beyond line of sight. Not as the only means of connectivity, but it can be an extra safety layer in case if you fly behind the building or you have bad reception, that you have this second communication mean. Then also we see a trend always lighter and smaller. That's also because of the legislation that lighter and smaller, if you stay below a certain amount of weight, that you get that you can do more with your drone. So that really pushes the market towards these sub 250 gram drones. And increasing autonomy, so more sensors and more functions that we can do with these sensors. So not just follow me, but also follow me between a forest and everything. So that's what we also see in the commercial drone market. And if we see, well, here it's an image from Skydio, but I've taken it, but it's a nice image. We see that we have increasing autonomy. So yeah, 10 years ago it was stage 1, and it keeps progressing. I think we are now, like Dromatrix is doing, they have autonomous operations, but they're also already working on a network. So what we see here is it's already being drawn on the tables, and this is already implemented, and we are somewhere here, what we see today. Autonomous path generation, so instead of just flying zigzag patterns to map something, or just manually clicking, this is the pattern I want to fly to map an object or to map an area, that we see that there are also innovations in autonomous path generation. So what we see here is a crash scene of a helicopter, and then all the white dots are points where the drone has to fly in order to map this situation and recreate the 3D image of this crash scene, which is, I think, an application that I've been hearing for a long time already, that emergency services or something, if they, or even for insurance cases, that it can be interesting to have a drone somewhere on location that just quickly scans the whole location, so that you have a 3D image for later analysis, and that you can quickly clean up the accident scene. And of course we have the military use that's also making some progress, but there we also see drones being more and more deployed. Here in this movie you can see that the soldier can detect a point where the drone has to fly and then explode, for example. But it's a bit scary. Certainly if you would also add some person recognition or something to it. And then a lot of drone docking stations. So that's what we see. The next challenge for drones is to have them deployed, not with the human going outside, putting the drone somewhere, but having a drone 24/7 somewhere ready. And therefore we need a docking station, which often requires more development and challenges than the drone itself to make something really reliable in all weather conditions. And we see a lot of them. So lots of drone docking stations. On the other hand, we see that going from applications with one drone, we also see that swarming, so applications where we use multiple small drones to have a mission instead of one big drone. It's also something that we will see. Then drone shows, which is yeah, a lot of drones. And also, yeah, there the drones don't have much intelligence themselves, so they're controlled by the ground. But there we also see many accidents where the drones fail, sometimes because a competitor like blocks the show of another competitor by going there with some disturbance radios or something to block the GPS. So also there, if the drones could like collaborate and estimate each other's position, they could come more autonomous and more safe in that way, that they don't rely on GPS and communication anymore. About drones coming out of the air, there are also applications where this is required. So for airport security, we see, especially after some incidents at airports, that there are huge investments to have anti-drone measures to make sure that in one area there no drones can enter. And here we have a laser system that points a laser beam some seconds on a drone, and then the drone will start to burn or melt and comes down. It's safer than shooting projectiles, I think. And then you also have other, so jamming radios, and that's what we also saw here in Brussels when the President of the United States visited here, that we had some team. I think it was more for show than for actual need, but we had some team here with some anti-drone gun too. Then also digital security. So we see more and more that people don't want to buy Chinese drones anymore because they might have some data leaks. So it's more and more, people are more and more aware of the security aspect of the data that drones capture and how to cope with that. We see more and more beyond visual line of sight missions, where I think a lot of potential is for the drones. So this one is from a delivery startup, Mana. And then also, okay. Yeah, okay. And then also we have, yeah, we see that because they want to use drones more 24/7, they also need to cope with some harsh conditions. This is a very harsh condition, it's at sea. So there we have everything in one picture. And therefore also it's very important to check for all the components of the drones that they are able to cope with these harsh conditions. So in aviation, it's already known, like you have icing issues. They do a lot of tests on all these components. And that's a trend that we see that also comes now to the smaller drones to do the same tests, to go to the same levels of safety for the small drones that are also small aircraft. So we also see that manufacturers for drones start to already think about this and also already put small product codes to have parts traceability. So if a customer has an issue with one of their products, that they can trace back the whole production line where this went wrong. We also see that to integrate drones in our society, that it's very important to make them silent, because that's one of the big problems with drones, acceptance of drones, that they are noisy. Also, if they're noisy, it appears that they are more dangerous. So if something is more quiet, it's much more accepted and appears to be safer. So there's a lot of effort going into the design of propellers to make them more silent. And then also this year we had the first drone on Mars, so the first drone beyond our planet. So the Ingenuity has landed on Mars. So that's also, I think, a big step in the aviation field. Drones for logistics, although there has been a minor dip, or some people expected more from it or expected it earlier, it's still something that continues. Maybe not for your pizza or your coffee or your Amazon package, but for conditions in which you have a really urgent transport that is really important. So, like for example, samples between a hospital and a lab. These are projects. So this is a project in Belgium where they're flying samples between a hospital and a lab in Antwerp. Something completely different. There's also some progress on the mechanical part. It's limited progress, or I wouldn't say it's progress. It's an alternative. So instead of having propellers, they use cycloprops, which is an alternative. But we've seen something fly this year with these kind of propellers.
There was something that.
Yeah, so different kinds of propulsion systems. So that's on the mechanical part that the people are still experimenting with the alternatives to propellers, although I believe propellers are still the most efficient way to go. And then I also see that drone technology, so from drones that are just generally flying, that like hybrids are being made. So this is a small robot that also has legs. And then, a big slide. This is, I think, a market or something that's going to be much bigger than the drones we have imagined today. But the market for unmanned air mobility, or urban air mobility, I'm sorry, is going to be estimated to be very, very big. But I could do a lot of slides on the unmanned air mobility, but that's something that we will see more and more. So to conclude a bit, not everything is solved yet this year or prior years. We still have a lot of technology issues that we can work on to improve drones. So we have the fully autonomous operations all week. Working tasks, so more applications where drones really do perform a task, not only sensing, but really manipulating in contact with the environment. Collaboration with other vehicles, safety, and energy density, so better batteries or hydrogen combinations. Long-range connectivity, data analytics, interpretation, obstacle avoidance is still something that can be improved. Localization, something that we are also working on, and then flight path planning. So that's my presentation for today. I would say, let's stay in touch, because I hope I could give some inspiration and some insight about what we are doing. So I'm going to tell you again that we at Flanders Make are really welcoming all ideas or questions to help industry move forward in Flanders. So thank you for your attention.